us a lot.
Yeah, okay, sure. Uh, just give me a second. Do you want it now? Just give me a second then. Sorry. Yeah. Okay. Yeah. I was also about to post the same. There's the link for the session, right? Previous session. Yes. Okay. My voice is better this time. Hello.
Yeah, this is good. This is good. Thank you.
Yeah. So, good afternoon. We will continue upon the revision session, last revision session. In the last session, we discussed about variables, shell and environmental, setting up the variables and subshells. We also looked at how to deal with arrays, indexed and associative. We also looked at how we can redirect an output to a newer command, how to use T command as well. And we also looked at exit codes and logical operations. Today, what we will do is we will look at the basic regular expressions, extended regular expressions, the concept of grouping, and then we will look at the global regular expression print, that is grep command, and we will also look at the stream editor, that is sed, and we will also look at awk. So today I would like to take a different approach. In the previous one, previous session, what we were doing was we were looking at each concept one by one. Today, I would like to discuss in terms of scripts. So, before I start, there were a few questions in the last session which I would like to answer. Just give me a second, I will start sharing my screen. Yeah, is the font size okay?
It would be
Hello,
great if it could be increased a bit.
increase a bit. Okay, just a minute. Is this better?
Yeah, much better.
Yeah. Okay. Um, So just let me pull up the questions which students have asked last time. Okay. So the key questions which were asked, whether can we decide order in the associative arrays like we do in indexed array. The other question which was asked was, when we do manipulate the shell variables or environmental variables, how do we use percent sign and slash and commas, right? Which we have seen in the lecture. And the third question was basically we can save output and error to the same file, right? So can we have an example where we send both output as well as error to the same file? So just quickly going back, how many of you were present in the first session? Okay, okay. I think Swati, you asked that question, was it?
Question on
Regarding the manipulation of shell variable, where the use of ampersand, not ampersand, percentage
yes,
sign or the black slash and all that. So just to give you an example, we'll start with that question first. So just a minute. Okay. So a very good example where we do shell variable manipulation is when we try to rename our files, right? So many a times we will get uh, we are in a situation where the data is automatically backed up, and then you have date and other variables which also are present in your file name. In such a scenario, it may become tedious for you to keep such a long name files. So most of the time, what people do is they will try to create a shorter files. So, for example, uh, so if I look at this particular script, what it so here we will look at the key concepts, two key concepts. The first one is defining a function, right? Here you see this part of the code is a function where I am asking explicitly, I am defining a function so as it will recursively go through a directory and rename the file in the way I want. So the first example which we can see where we do see shell variable manipulation is in here, where we are replacing, if the file name has old text, we are replacing with new. So the syntax, uh, if we uh, have the notes, lecture notes from the search session, we see that you have a variable name, that is file, and then you have a pattern which you want to replace it with the new value. So what if like, in this scenario it is only replacing if there is only one old uh, instance in the file name. What if you have multiple instances of this particular string called old. So in such a scenario, you just have to put a double slash here, old and then new, and that will replace all the instances of old to new. So in this instance, here we see that search and replace is being done. The other place which we see that shell variable manipulation is being done is in here, where we are asking, we are basically, so you have a file variable. So in file variable, let me just quickly pull the, yeah. So uh, yeah, so if you look at the uh, this particular command, right, where they are using hash, right, you're basically asking it to remove all the pattern, the maximum pattern, which till uh, like, uh, if after the dot you have txt, right, this is what it is trying to compare. Only when you have this condition met and this condition met, where it is a file and it is also, its extension is also txt. So basically you are removing everything before the dot with this command. So if you use just one single hash, it is just removing once. If you do two times, it is removing all the instances of the pattern. So this is where they are being used. The other concept which we look at it is how conditionals are being used. So there are two ways conditional are being used in this simple script, where we are recursively going through the directory. In the first instance, question. Okay. Yeah. So the other thing where you need to look at is the for loop, right? So in a for loop, you are recursively going. So for loop starts, the basic format of for loop is for um, I, and suppose I want to iterate over 1 through 10. I'm asking it to do echo $I done. So in basically what your syntax is, you need not write all of this. So each like in the last revision session which we have discussed, that each semicolon is basically a new line. So we say do echo $I and then done. So basically these two are equivalent. In the same way, we see that it is recursively looking through a variable called file, which the first input of what do you call it, uh, the first input argument, and then it is going into the if loop, where it is asking whether the file is a directory or not. If it is directory, then rename the directory, where if it has old name into it, then you replace the old name into new, and this is being stored into a variable. Again, we are seeing how the variable is being assigned, and it is moving, that is, it is renaming this old file name with the new file name, where this is the new format within which it wants to do, and then it is finally echoing that the directory has been renamed. Otherwise, it is telling you that, if you look at in the slide, elif is that it is again checking whether it is a file, and if the file extension is txt. So in my case, I'm sorry, So in my case here, look at the. So I have some MD files also. So MD file is nothing but markdown files, and I'm converting all the text documents into markdown file and moving into, sorry, the new file name, and it is again printing it. And then finally we are calling that function and we are asking to operate on that. So basically, if you want to so first of all, if you one can generate numerous functions like this and save it into a file, and this file can be saved into the current working directory or the user directory, user script directory, uh, where from where you can source easily these files and then call these functions while in your scripts. So if you go here, yes. So uh, in case of uh, the question, right, where you ask what is the use of percentage sign. So in a percentage sign, what essentially happens is that it will match only, it will try to keep the pattern as is if it matches. In the same way we do with backslash. 1 minute, just pull up a script. Yeah. So anyways, I'll go ahead and answer the second question first. We'll get back to that again. The second question, which was asked, whether an example where output and error is sent to the same file or not. So previously we saw that ls and l, and we were trying to send this output to some output.log file, and then we also wanted to send the error to where the, sorry, to where the output is. And this was the way we can save the error. So the question was, is there a command where we can actually test it? So it happens that it is very simple in this scenario. Suppose I have a data.csv file, and suppose data x.csv, which is not present. In this scenario, it will produce both error as well as output. If you look at it, it says that data x.csv is not found, no such directory, but data.csv is present. And this is what we see, that when we cat the output.log, this output as well as error is being redirected. There is another example where we can look at subshell concept, where you basically uh, so in this, what we are asking is launch a subshell in which you are uh, asking that ls-a command, as well as once it is done, only then execute ls-z command, and output of that command is, of course, you have the list of files, and then it says that it's an invalid option. So that's an error. So when we look at it, if I just say output.log for 1, and then for 2, if I say output dot error, So if I do cat dot error, we say that the error is separate, and then output dot log should have all the output successful output of the first command. So what if we do both of them to one is to send it to where one is, that is output.log, and in this scenario we should see both being sent in the same file. I looked at another command where we can use t as well, where we are not only, so suppose ls l lsa, then I would like to pipe this command to t output dot log, so it should print the same cat output dot log. So in this case, t is outputting both the output of the ls hyphen a command as well as it is putting that into this log file, and then I can ask, I can go, and if that is true, then run ls hyphen z also. So in this scenario, you'll see the same output, that you have output as well as then you have an error, and this you can directly send to, and because you already are saving output dot log there, right? So you would like to append it. Output dot output one dot log, and then send the error also where first one is, and this should give us at one dot log file. Should have error as well. So anyways, that was one of the two examples which I could find out where you can do, you can send both of them to the output. The third question was regarding associative array, and if you look at the previous example which we had taken, so previously what we did was we declare an array of one, so that, just copy it 1 minute. Where we have key 1, so instead of that we can just do array1 dot key 1 is equal to test1 array1 key 2 equal to test2 array1 key 3 equal to test3 array1 set1 equal to test4 5. So the question was echo so for key in dollar take all instances of array1 at 2 echo to dollar key and echo and the question which was asked was just a minute. Yeah, so basically what we did was basically we went and we first gave the key 1, then key 2, key 3, then set 1 and set 4, and why there is no particular order to the way we see the output. So the quick answer to that is that unlike indexed array, which uses index to store the data or to store the value, the associative array uses keys which are usually mapped to the values. So the difference being the order in which these keys, the values are stored in the keys, is decided by a hash function. So it is like a hash table, and which is why the use cases for the indexed array as well as the associative array are different. So uh, for example, in an awk, we'll see that when we need to count instances of certain variables, we will use associative arrays. But if we want to just add them up, right, we will use indexed array. So we'll store the value in the indexes and then sum it over, iterate it over such that we get the average at the end of it. While in case of keys, we will keep on comparing and adding, iterating and adding uh, the values if it is repeating again in case of associative arrays. So those were the questions which were asked. So moving forward, we will first look at the grep. Even before we go to grep, we will look at the GRE and ERE. That is, what is your regular expression types? That is general regular expression or extended regular expression. So I have a file prepared for you here. Mm, yes. So uh, give me a minute. Huh? I'll, while you go through this, just give me a minute. I'll be back. Yeah. So if you look at the sorry, if you look at the screen, the regular expression fundamentals revolves around a few of the key characters. So there are quantifiers such as star, plus, you have question mark. So what star essentially means, for example, when we do ls star, we're essentially telling them to grep anything 0 or more. So it will try to grep everything. uh, uh, it will try to list out everything which is there. If you have plus sign, that means we want an instance of one or more. So suppose you have a character like, um, suppose Alice is the name, and you would like to know whether you want to have a whether it is an Alice or whether it is an Malice or an Alice. So, in case you want to match with all of these conditions, all you need to do is plus. Let's see. So that will match with all the four instances. So essentially, you're telling that one or more instances of that. If you have a question mark, it can be an occurrence of one zero time or one more time. Uh, Besides that, you also have a dot character which says any one character except new line, that is /n. The next important aspect is that you have also uh, a counter, like exactly how many times you want certain things to occur. For example, in case of mobile numbers, you may just want to have uh, like in this case, if you want to what do you call it, if you want to match any of the digits, either you will use 0 to 9 or you will use this format POSIX class, which is digit. And you want to know whether if there is a 10 numbers, suppose you have, then you will just simply do digit and you'll just say in a bracket 9. Now this is 9 or 10. If you know that there are 10 consecutive numbers you would like to look for, you can simply just use this format to look at those. uh, the thing with the GRE and ERE is that uh, in GRE you need to escape uh, this, as is a special character in shell. But if you are using the ERE format, you don't need to escape this character. So that is one of the major difference, that if you have question mark plus parenthesis, braces, and an or operator or the pipe symbol, then you need to escape them with a backslash in order for it to work with the GRE. Where in case of ERE, you need not use it, as it gives you that option to not use it. So we'll just quickly look at one of the document. And this is something which we use, like the pattern matching is very important if you want to uh, operate on a file where we are using grep, sed, and awk to manipulate the file. So I'll just cat. Yeah, we'll start looking at grep command. So if I have man ls grep exit at ls Yes. So here is a simple example where grep is being used to find the instances of Alice, all the instances of Alice. Just give me a second. Just- I'm back. So we have one more file here, cat data.csv, which contains phone number, name, email addresses, GPS coordinates, and a unique number associated with that person. Right. Suppose using the GRE, we would like to uh, only select the phone numbers with this particular format. Let's put this a little. So grep, we'll just start with all the digits. Digits. Dot. Yeah, now it is gripping all the numbers. So I'll just now I know for a fact that so in grape you can use either the regular grape with the GRE. If you want to use it with ERE, you just need to say grep E. This will give you a chance to make it into extended regular expression. It will give you a way to use extended regular expressions. And I know for a fact that now the number is divided into 3, 3, and 4, where you have parenthesis in this case for the first three numbers. So let's try to get that. So you have this, and then you have 3, and they have another parenthesis. So you have only now last one. Have again shit 4 times. To get CSV. You have then another format where you have in this particular format. So if you can make it into a group, it starts with this. Or you want to have a single digit followed by dash. Single digit followed by dash, and then you have 3 instances of digit.
Sir, you have to use OR operator, no?
Sorry?
You have to use OR operator.
Yeah. Just a minute. I'm just cross checking. It's matching, right? Oh, where to go? Oh, E. No, or operator is pipe symbol, right? Where it go?
So then,
Sorry?
what is double pipe symbol?
No, in grape it is double pipe. It is not. When you use in grape command, right? Cannot use double pipe symbol while matching the pattern. The pipe has to be escaped.
So please use in the and na.
Where? I messed up again somewhere. What are you saying? Hello?
Hello,
Yeah. What are you suggesting?
sir. Sir, you continue. Sorry for the interruption.
Yeah. File name is. This should work. Just a minute, I'll just quickly run. Scatterless txt grape. So we want to have an instances where two words are matching. So to and that is what we should use. To or that in this txt. And it will give you all the instances of either to or that. In the same case, same way, it is supposed to give you option for both. Because it's such a long string, I don't. So it should essentially show the lines where both of them are present, not only one. So because in this scenario, it should not show any of the lines. And it's the other way you can do grep is also, if you know. So if you looked at do that in ls, you can also do something like this. -e and e ls, and it will do the exactly same thing, but essentially you're asking in two different sentences. Same can be done with the set command also. So if you have sed, let's look at ls. Sed ls should print all the file as this. If I just want two lines, it's not getting double printed, right? We're looking at grep. What if I do like this? Then I can and then the original one was. And here we see that in the second one, right, it is printing all the lines which has either two also as well as that. But I think in this scenario that both of them has to be present in the same line. So you can use AND operation like this in grep and OR operation like this in grep, where you can use either -e or you can just simply put a OR symbol. But if you're using simple grep, you should use it like this, or if you want to use extended grep, you can just simply put -e, and then remove this, and it should give you the same output. In the same way, I was thinking that it should be able to print all the phone numbers where both of them is present, both the patterns are present. So we'll just go back to that example and put another grape in there. See what happens. Paste data .csv. Pipe that to grep. Finally, go to know this. Okay. Are you guys okay? I know the problem. Now that should work. This should also work. So you see that in this case we have this phone number present also, and in this scenario also we have one with the bracket. But when we do an OR operation, on both it is not working because whatever output you are getting from the first command, right? So the first command is producing this output. It doesn't have this. Sorry. Yeah, because this doesn't have this particular set of what do you call it? Output. You will not get any output from this particular command. So instead of that, I will use E here and E here. We'll go paste data.csv. In this case, we should see secretly there is no alias with the small letter, it's capital. And then you should be able to see both the instances being played out. In the same way, if we do with this, it should list out both the instances. Is there anything wrong with the code? Hello? Hello? Yeah. So this is what we do for both the instances. We can do this easily. The phone number maybe not. Cat test data. Okay, so we'll get back to this. We'll move forward and I will look at the sed and awk. I think I would like to start first with awk and then we'll get back to sed and grep again. So so basically awk usually has a typical format in which you have a begin block, then an action block, and then you have an end block at the end, which can be operated on file. You can also write a command if you want. If you can write, you can also write a script and then exactly put this in the script, and it can run on any of the file. So basically, begin block executes everything which comes before executing on the line. So if you want to set up some variables, you want to specify what should be your field separator or what should be your record separator, input field separator, output field separator, you need to put that into begin. Whatever process you want to do on subsequent lines, or if you want to only process certain set of lines based on certain filtering criteria, you can use the action block for that purpose. And then in the end block, if you want to summarize it, whatever you have found here, you can easily put that here and print it out. So basically, this is what the awk's baseline format is. So if we look at that data again, so just to simply print the data, you can just say print. Suppose I want to print $1 and $2 of your data.csv. You can see that the first column and the second column is being printed. So let's just use the process data. So in here, the first set is name and then phone number. And you can see that the name and the phone number should be printed, but it is not because our field separator, which can be easily defined, then you get the first and second block. So by default, what awk does is that. So let me see. Yes, CSV file is there. Okay, so if you look at this course file, it's field separated by spaces, and your awk is usually designed where your basic field separator is the field separator is space or tab value. In this particular case, if when I'm talking about the record separator or the field separator, the field is essentially each column separated by a particular in this particular set, it is by space. It can be also by comma, that is comma separated values, as was the case with the previous one, test data.csv. Here we see that the field separator is comma, and because we were asking it to print the first and second column, what it was doing was it was trying to find out the first space character. So if you want to define what should be your a field separator, either you can do it like this, or you can in the begin block define in fs is equal to comma, and then it will do the same. Same way, if you want your output field separator to be different, you can just say output field separator to be maybe like, sorry, this, and all the arguments should be separated by semicolon. And here you can see that you can easily transform this file into from comma separated value to your colon separated value. So basically field is your column and record means your lines. So if you want to by default your output record separator is /line. What if I want to change to //? Sorry, again the same mistake. And then we see that all the lines are not now into the new line, but your double slash is your output record separator. So this is the way you can do the record separation. What if you do not tell what should be your output field separator? So by default, if you just use comma here, like we have used in this case, the columns will be separated by a space. So when you say comma, it is by default it's a space. If you remove this, essentially it will catenate the columns and it will generate one single column, which is not what we want. You can also define your field separator here like so. I can just put it in double quotes and tell that I want this two to be tab separated, and then you can see that now these are tab separated. You can also so when you say print $0, it will print everything. What if I want to only print all the instances where Alice was there in the text? And this way you can also do the same thing which grep is doing, where it is actually printing out all the instances of Alice which was present. What if I want this not to be the case? So I just use not operator like so. Sorry, not here, it should be here. And then all the lines without Alice will be printed. Such is not the case with the grep. If you do grep and you want all the lines with Alice and Alice dot txt, you see all the Alice is being printed. And what if I don't want that to be the case? I'll simply say not Alice. It's instead to suppress the output. Yeah. So in case of sed, you can just simply print the rind with matching with Alice by using so. And if you don't want, if you want lines without Alice, you can just put that apostrophe here, and it will just filter out all the lines which doesn't have Alice. Which is exactly opposite if we looked at awk. In awk, first we say not and then the pattern, and then it will print all the lines which you don't want. You can also do an operation where you can do uh, something, a simple example where I am just counting the number of lines. I'll just show you. So if I do nano count lines dot awk, so chmod add, so you can simply call your script like this and then provide the file as an input, and it will tell you that there are totally 23 lines. And if you look at the code itself, we see that in the begin block we have set a variable count is equal to 0, and then we are just counting plus plus where it processes each line, each record one by one. So when it processes each record, it will just increase by one, and then at the end it will tell what the total number of friends. So you can just add a condition here if you want to, just like we saw, that print process all the lines which doesn't have Alice uh, in it. And if you just save this, and then we run, we see that it is processing everything, but it is only printing the line where Alice is not present. So if we go, so basically what it is doing, that it is processing all the lines, but it is printing in this particular case only the uh, yeah, it is printing the printing all the lines without any uh, Alice. And this happens because by default, even if you don't give any input to the awk command, suppose we just say awk, and just see what it does. Thing. This is what they use. So what essentially is happening is this one is by default is at the end. Whenever so either you can do this or you can just say simply print, and it will print all the lines. It does the same thing with both the cases. The other thing which I wanted to talk about in awk was uh, looked at this course data set, right? This city score. Sorry. And we see that in first, second, third, fourth, fifth, sixth, seventh. We can't use this. Mm. Let's create a file. So if we look at this course too, we have all this information. What if you want to use awk to calculate the averages? So like I said initially, that we can use something called indexed array also, or we can just simply keep on counting, keep on adding so just to simple scores.csv, and in the end what I want was avg divided by nr print average is avg. And then we can just go in the begin block where I want to iterate through all the columns and need to find out total. So you have total 1 plus equals $2, then total. I'll just do with this one first, and then you want to define the field separator also, because we are using this one. It's just for print total. So total it is printing, and I want it also print nr 6 total by nr. That is what it is doing. So this is the way we can iterate over. So essentially what it is doing, that it is going from each element. But here we have to make sure that because our first line is the title rhyme, so you want to tell for all the NR which is greater than 1, it should do processing. And we have to remove 1 here. We have to get the actual averages. So the reason behind I showed you the script was that essentially awk was initially developed to do quick and dirty calculations just by using single line commands. Nowadays people are using awk in a really huge programs. So there were some programs which were developed which acts like a dictionary or for grammar check also. So there were some preliminary uh, so initially a few of the people actually went ahead and developed it full uh, as a full programming language. So aside that, just a minute, give me a minute. So this was also one of the one line code which I had developed, uh, where we are using an instance where we are creating an indexed array where we see that the data is being stored, where NR is your index, and then you're storing a $1, that is first column of the file. You're summing over it. You're also uh, storing into this data, and then you're calculating the average, and then you're going over this array. So this array is basically created in order to keep all the instances present in the first column, which is required when we do the calculation for the standard out deviation. So data I, so for all the instances of I, we are calling here and we are subtracting average and we are squaring it to find the standard out deviation. We are using sqrt functions. So awk also supports many mathematical functions which you can use. Apart from mathematical function, it also supports shell functions such as file name. So you can be very creative when you start using awk to do much more complex jobs using those functions. Besides that, like I showed you previously also, we can design our own functions and source them into your script as and when necessary. uh, Another instance I wanted to show you is how we can use associative array. So this particular code was written to look at, so we have a people's data where we have people name and their age in the next column. So essentially it is like name comma age. So the script operates um, on this database where we are storing the name of the people. uh, so just let me just get that file for you. So nano. And so this particular function, this particular awk program was written in order to rearrange as per their age. So we see that in the original file, we had given in a random way, and here we see that it is now, what do you call it? It is now sorted. So here we are using the information which is present. We are assigning $2 to $2 and $1. We are creating an array which contains the key $2 contains two sets of information: people and the age. And in the end, we are iterating over this array. So yeah, iterating over the array, and in there we are using a function called substring to extract certain information, and then we are putting we are using length, another function to calculate the age, to sort out the age. So this is one of the instances where they have used associative arrays, where you store in the key to arrange or to count the occurrences and so on. So that was all. I think we'll try to have one more session to do the SED. Yeah, branching in SED is what sir has talked little bit about, and it is not a big part of the syllabus as of now. So I think I will have one more session, maybe tomorrow, where I'll ask also Santana to cover the other this commands you are talking about, right? Xarg and proc and all that. But essentially, in the exam, what we will be testing you is on the sed awk shell scripting in general, and then the variables. So will you be able to identify all these patterns in a program, and will you be able to answer based upon the information provided? So that is all for today. The next session, if you plan, I will send the link to you. So thank you very much.
What is just one question? Like in all commands, if in case like a field separators are more than one, so in that case, how can
you
we
can use, actually you can have more than two field separators also.
Okay, and that in the same parenthesis.
Same parenthesis means?
Like in begin we give fs and we within one like put we give that in case like if for example if it is uh, space and comma, so we'll be giving space and comma both
So
at
what
this.
usually essentially people do in awk is, right, you just so in this case I'm just saying, we use this concept, right, in call it so in regular expressions, right, you usually say, okay, I want to say, suppose you have a, b and c. So essentially what we are trying to say is it can either be a, it can be either b, or it can be either c. In such a way, in that sense also you can have multiple field separators also included just by
Yeah,
using.
and begin we give the fs and then
Yes, yes.
okay, thanks.
Yeah. Any other questions? You can just tell me so that I can include some discussion in the next section. Okay, then that is all. Thank you very much for staying till the end. Uh, I'll try to be more ordered
Just one
next
last
time
question.
onwards. Yeah,
Yeah,
yeah, sure.
like is there any weightage for different like weeks for this exam, final exam?
Different what?
Weightage.
Weightage. So which weeks will be weighted more as is?
Yeah.
Yeah, yeah. So essentially, like I said, the exam will be conducted only on your understanding of variables, Z, awk, grep, general your GRE and ERE concepts. So if you don't need to remember all these commands and everything, because all those data will be provided. But what we will be testing you is for the logic. Given all the information to you, will you be able to understand the question and give the answer?
Okay.
So as such, if you say weightage, right, the syllabus which sir has covered is very vast,
Mhm.
and to cover each part in exam is also not possible. So what we are actually testing you for is actually shell scripting, basically,
Okay.
and nothing more than that. So if logically you can understand certain set of questions, like how to use GRE to grab certain patterns, or how to use that into SED and knock, or how will you do numerical calculations, or if you want to do count and so all these mathematical operations, or operation uh, which you may encounter in day-to-day system administration, is something which you will only touch upon in exams.
Sure. Thank you.
Yeah,
Thank you.
yeah. Thank you very much. Bye bye.